All right, and now for this fourth one, they tell us that it is known that the weights of male Persian cats are normally distributed, those are huge buzzwords, with mean blah and variance blah. Okay, and for part A, we need to sketch a diagram above showing the information. And so, when we're in the land of normal distributions, we have three main tools, okay, that I'm actually going to put down here. They're these, okay? And so I actually have like a cheat sheet. We have normal PDF, normal CDF, and inventory normal. Those are my three tools. Where can I find those tools? In your graphing calculator. In your graphing calculator, right on top of vars, you have this little thing that says distri, makes reference to distribution. So you press the blue guy, you press vars, you go to the distribution. The first three tools are right there: PDF, CDF, inventory normal. Same stuff I had down here. All right, and so as they show up, we will be using them. But just know those are your tools. Okay, a lot of the IB and a lot of my videos you're gonna notice is not so much knowing like some fancy math thing. It's just knowing the fucking tools you have and when to fucking use them. All right. So part A, we have to draw this. Okay. Sketch a diagram. We know it's normally distributed. A normal distribution is also called many times a bell curve. Okay. So we will literally draw a bell curve that looks like this. All right. And I'm just gonna say right away, the guy in the middle is this, which is your mean. Okay. And 1 over. Okay. You have your mean plus 1 of this. And that is your mean plus 1 standard deviation. Okay? So 1 backwards would be your mean minus 1 standard deviation, and you keep going like that. Okay? Now I'm going to take a moment and just say like why the normal distribution is a big deal in the real life. And it's because this pattern of like how stuff gets distributed actually repeats in a lot of ways. For example, if you take the average weight of a baby at birth, of like 1,000 of them, at some point you're gonna end up with something that looks literally like this. Okay? Why is that relevant? Well, because this area and this area makes reference to a certain percent. This area and this area makes reference to another certain percent. What am I talking about? Talking about that. So if you see what's in green, the big chunks, which is just one standard deviation over, makes reference to 68% of your population. Two standard deviation over, which is where I hit the yellow stuff, is 95%. Where I hit the red, which is way, way out, it's going to be 99%. Right? So just know that the normal distribution actually has like purpose behind it. Okay? I mean, most of math does, but I'm just going to point out, some of this stuff applies in real life. So, if we're sketching the diagram, we do have to go 3 standard deviations out. Okay, that's just the kind of thing that you have to be aware of. And so, there it is. Okay. So this is sort of like my base for drawing it, for sketching it. And my next step is filling in these numbers. Okay. So what is my mean? Well, they told us that the mean is 6.1. So I'm going to go ahead and I'll do it in red. Okay. So this mean right here is going to be 6.1. The number on the right is one mean, right? Plus one standard deviation. What the hell is my standard deviation? Let's see. Here we have variance. Okay, so they tell us that my variance is 0.5 squared. And I know that looks kind of weird, but they actually do that in a convenient manner. Why? Because your standard deviation is your variance square rooted. All right. So standard deviation in this case is going to be 0.5 squared rooted, which is just going to be 0.5. All right. The root and the squared are going to be opposites. All right. They are inverse functions one to the other. It just kind of crosses out. You end up with 0.5. So I can immediately say that my standard deviation here is indeed 0.5, which is not something that shows up in this exercise, but it's also why the normal distribution, if I were to write it out in very, very fancy math words, would be like this: 6.1, comma, 0.5 squared. Because the normal distribution, you write it like the mean and the variance, which is standard deviation squared. Okay? So that it's actually kind of useful that they put it squared in this case. You can tell that the standard deviation, which is just this, is just going to be 0.5. All right, that was a lot of blah blah, but it's a little bit of the context of what is the normal distribution and all that good stuff. See, so if I'm going to finish sketching this, I have to do 6.1 plus 0.5, which is going to give me 6.6. See? Just so that we're all on the same page, here I did 6.1 plus 0.5. Why 0.5? Because we are adding one standard deviation. One standard deviation is this guy without the squared. See? Nailed it. So if I go backwards, it's going to be 6.1 minus 0.5. You end up with 5.6. All right, so that is my approach to sketching it. First, you have to draw it like a bell curve, and second, you have to plug in the right numbers. See? So if I'm just going to go ahead and do that on the left, I do minus 0.5 again, I end up with 5.1, minus 0.5, I end up with 4.6. On the right side here, if I add 0.5, I'm going to end up with 7.1. I do it again, 7.6. All right, so that would be for sketching my whatever, man. This is part A. Okay, this is for sketching. You have to do it that way. You have to plug in the numbers. Okay, it's not just about drawing the figure. You have to plug in the numbers. So that is part A. All right, and now for part B, we have that we need to find the proportion of male Persian cats weighing between keyword 5.5 and 6.5. So between 5.5 would be this guy here, and this guy here 6.5. All right, so as I said earlier, these are 3 tools. You can take a quick glance and like already tell me which ones we have to use. But I think it's more important to understand the intuitive method and like the the approach that I like to share or that I hope that you learn when you watch these videos. And so like the whole point is that I don't know, whatever. You're taking this test, you're like a little stressed out, and you don't really know what the fuck is going on. But you know that this is about a normal distribution, and you know that your calculator has some tools. And so that is the main thing like that I like to teach. Dude, what are your tools? How do they work? And so when you're in the middle of the test, you can kind of figure out which tool to use. No one, or well, no one is a strong word, but most people don't memorize which tool to use in which scenario perfectly. All right, but I do think it's very important that you know which ones exist, how to reach them, and intuitively figure out which one you're supposed to use. And so you somehow remember, or you will remember that there's tools in your graphing calculator, and so you know that it's in distribution, right? So you go second vars hit distribution, and you know that it's these 3. Now, you don't recall which one to use because no one has godlike memory, and so you go one by one and see what it asks for, and from there kind of tell what it gives you. And so normal PDF, I see that it asks for an x value, it asks for a mean, it asks for a standard deviation respectively. And so in this scenario, you put just one x value. Here, I have 2 values between 5.5 and 6.5. And so because I have 2 x values, that's already not good enough. I know that PDF does not help in this scenario. See? And well, let's take a second and read. PDF gives us the percent of the data result that falls exactly on one given score, which makes sense. If I plug in only, say, 6.8, right, I'm going to find the percent of nailing 6.8. See? Of getting a cat that weighs 6.8. Let's go ahead and see what happens, right? So I plug in x value 6.8. Mean we said was 6.1, I think. Yes. Standard deviation was 0.5. And so the intuition here is that there's around a 29% chance of getting a cat that weighs exactly, careful, exactly 6.8. See, so that is PDF. Now in this case, as we said, PDF does not help because we are talking about a range. See, we are talking about between keyword 5.5 and 6.5. And so we're trying to find the proportion or the percentage of cats that weighs between 5.5 and 6.5. So we keep going. See, I'm actually going to go with inventory normal now. Here, it asks you to give an area, and again, you give mean and standard deviation. And so inventory normal works a little bit backwards, right? You were giving an area, say that I know, I don't know, that this here is 7%, but I don't know what this value is or what this value is. Inventory normal can help you figure that out, okay? And usually, actually, now that I remember reading this quickly, it would be like, you know that from here up until somewhere is 20%. But you're not sure what that somewhere is. You don't know the weight of the cat that goes here. Inventory normal helps for that. Okay? So just that we're on the same page of what our tools do. That's PDF, that's inventory normal. CDF, the one that we actually have to use in this case, the most intuitive one to my liking, simply asks for a lower and an upper, mean and standard deviation. The reason that it comes like this, which is -1 E99, this is basically like a very big negative number. Okay, and when they put E, I think it's just 10, right? So it's like -1 times 10 to the power of 99. So it's a massively negative number. Okay, so all that it's really doing in this scenario right now is that your lower end is all the way over here. Okay, but our lower end, we want it to be right here, which is at 5.5. So we're going to take this guy, change it to 5.5. So now our lower is not over here. It is indeed where I drew it before. And our upper end is going to be over here, which is at 6.5. So lower, upper, mean from the problem, standard deviation from the problem, paste. Boom, 0.67307. So for part B, because we got this number here, if you want significant figures or whatever, you end up with 0.673, which is the same as 67.3%. And so the proportion of male Persian cats weighing between 5.5 and 6.5 is 67.3%. All right? Awesome. Nailed it. So that's part B. Later on, they tell us that a group of 80 male Persian cats are drawn from this population. And we need to determine the expected number of cats in this group that have a weight of less than 5.3. And so, because we're talking about expected number, that should already be ringing a bell. And because we're talking about less than 5.3, that should also be ringing a bell. And so, what we need to do now, let me make some space in our little diagram here. If we're talking about 5.3 and less than 5.3, see, that means that we need to find the proportion or the area or the percent from 0 to here. All right, so that means my lower end is going to be very negative and my upper end is going to be at 5.3. So that is the first step to find the proportion of cats that weigh less than 5.3. All right, so calculator. Whoops, sorry about that. Normal CDF. My lower has to be a very negative number, which I could do before, like -1 times E times 99 and all that shit. But just make a very big negative number is gonna work. See, so again, intuition is what matters. I'm just gonna put a very negative, big negative number, and my upper is gonna be 5.3. Mean didn't change, standard deviation didn't change. I get 0.05. See? So I'm gonna write that over here. We found that the percent, right, of cats that weigh less than 5.3 is around 0.5. Sorry, 0.054799. Let me just make this a little more clear. That is a 0. All right, so this is the percent of cats that weigh less than 5.3 kilograms. See? And so if we're talking about the expected number of cats, expected number of cats in this group, of which group? Of the group of 80 male Persian cats. See, so group of 80. So I take this percent, I'll multiply it by 80, and that is my expected number of cats that weigh less than 5.3 kilograms. See, so I go ahead and do this. Pop it into my trusty rusty calculator. Boom. 4.38. 4.3839. If you want to get fancy, this is the same as 4.38. So in this group of 80 cats, my expected number of cats that weigh less than 5.3 is around 4. See, more specifically, around 4.3. 4.38. So, I know these are a lot of numbers on the screen, but essentially you're taking the your proportion and your total. So you take the proportion multiplied by total, that's going to give you your expected value. expected number. See? Proportion in this case is a little bit like probability. All right. So your probability times your totals can be your expected number for what they were asking for. See? So that is how you treat expected number. See? You first need a sort of percent, and then you multiply it by a certain amount. All right, and now for part D, we have that it is found that 12 of the cats weigh more than X kilograms, and to estimate the value of X. Now, which 12 cats? Well, the 12 cats from the group of 80. Ah, so we're still talking about expected number, I see. Exactly. So down here, let us remember that I did point out a sort of equation for expected number, or amount, or whatever, which is expected number equals your probability or proportion of your area, ¿cierto? Times your total. So expected number in this case is 12, because we're talking about the 12 cats, equals your probability or proportion. See, I'm gonna put prop. See, so prop for proportion times your total, which in this case is 80 because there are 80, the group of 80 cats. See, divide both sides by 80 to get proportion alone, which is essentially my variable. Your proportion in this case is going to equal 12 divided by 80. See, and so that's gonna give you. Let's find out. 12 divided by 80. 0.15. See? All right, and from this step forward, I'm just going to say right away, depending on which calculator you have, you actually can skip some of the steps I'm about to do. But I'm just going to show how you do with the TI-84 because it's what I have at hand. All right? But point is, this 0.15 is telling you that your X value, see, moving from left to right, ¿cierto? At some point, you filled in 15%. So let's say that you fill in 15% around here. All right, so this is from left to right 15%. That means that I have a value of X here. ¿Vale? Now, it's not exactly the value of X that I'm looking for here, because this value of X is any of the cats that weigh more than X kilograms. And this 50%, again, goes from left to right. So from 0% to 50%. ¿Vale? So, essentially what I need to find is the top 15%. What I just found is the lower 15%, right? Interesting. So I actually have to find, say, from here to here, right? And this value of X is the one we're actually looking for, okay? Not the one that I have on the left, the one on the right. And so, why is it useful that I know that this area on the black on the left side is 15%? Well, because if I do, say, 1 minus this 15%, which is the same as doing 1 minus 0.15, I end up with 0.85. So let's take a moment and think about it. This whole thing in, say, red is equal to 1, okay? This thing in black that I put earlier is equal to 15. And so if you take away what's in black to the red, ¿cierto? You end up with 85%, right? And because these diagrams are like, these normal distributions are perfectly symmetrical, right? This top 15%, I mean, this bottom 15%, the same amount of area as this top 15% here, see? And so what that actually allows me to conclude is that intuitively, this guy, to reach up until there, okay, which is just taking the red and subtracting the black, you end up with yellow, which is 0.85. So that right there is going to be 0.85 as an area, okay, which is the same 0.85 here. So you subtracted the 15% over on this end, right? That's how you can look at it. There's the 15%. The one, as I said earlier, was the the red, sorry, which would be like everything. And you end up with yellow, which is 85. All right, so color coded, it's a little bit messy, but I hope you got it, the intuition. Point is, everything in yellow is 85, see? And that is the amount of area you need in order to reach the cats that weigh more than X kilograms. Now, what the hell is X more specifically? Well, that's when we use inventory normal. As you see, inventory normal is asking for an area. See, so I go to second vars dist. Inventory normal is asking for an area. So if I plug in the area, I should be able to get the x value that from then forward is what I need. See? So if I go ahead and plug in 0.85, mean of 6.1, standard deviation of 0.5, it gives me the x value of 6.68, sorry, 6.618. So 6.618. Which if you want to get fancy, you can do the significant figures and all that stuff. You end up with 6.62. All right. So this x value here, which I of course did not draw to scale, but 6.62 onward, okay, is going to be exactly what I was looking for. So now that I'm actually drawing it like to scale or how it should look like, this in yellow that I'm going to put now is 85%, all right? And everything to the right of that is anything that weighs more than X kilograms, see? All right, part D is probably the most confusing one. So I hope it was clear that like, let me just make a mini review, ¿cierto? You know that you're working with expected numbers because we're talking about 12 cats, and you have to wonder where those 12 cats come from. They come from the group of 80. So that's when you know you're in the realm of expected numbers. And once you find the probability or the area of that, you have to remember that inventory normal is asking for area, so you probably have to use that. So we use inventory normal, we get the x value that corresponds, 6.62. So that is for part D. All right, and now last but not least for part E, we have that 10 of the cats are chosen at random, and to find the probability that exactly one of them weighs over 6.25 kilograms. So here, we are choosing at random, and we're talking about a group of 10. All right, so we have a group of 10 that's going on. I'm going to find the probability that exactly one of them fits a certain condition. Now, this is now sort of a different sort of distribution because we're trying to see if one of the cases fits a certain condition, right? Like that's like the big hint, whether they fit a condition or not. We are now talking about a binomial distribution. And so a binomial distribution is usually like, I don't know, flip 10 coins, 4 of them are heads. Probability, and you work from there. See? And so in this case, it's no different, just that your quote-unquote heads or quote-unquote tails has to do more with how much the cat weighs. See? So in this case, instead of flipping 10 coins, we have get 10 cats, and we have exactly one weighs over 6.25 probability, and that is, this is part E. Okay, I just want to point out that it's a binomial distribution because it's very similar to like the original scenario, which is heads or tails. Just that instead of heads or tails, we are seeing the condition of does it weigh over 6.25 or not. All right, so that's a little bit hard to grasp, but I think that's probably the best way I can put it right now. Okay, so binomial distribution, what do we have? Well, let's open up our calculator, go to the distribution area once again, so it's second bars, and scroll, see what's up. So you scroll for a bit and you end up finding that you have binomial PDF and binomial CDF. So you open up binomial PDF, see what it asks for. So it asks for trials. I'm just going to put binomial PDF. It asks for trials, X value I think it was. Yep, sorry. First a P and then an X value, all right? P is going to be the same as probability, all right? Just so that we're all on the same page. Let's see now what binomial CDF is asking for. We can see that it asks for literally the same thing. All right, so this is unfortunately one of those things that you might have to memorize, but I'm sure if you play around with it or put the same values, you can kind of like have intuition of what it's giving you. All right, and so I'm just gonna say right away, binomial PDF and CDF ask for the same stuff. Okay, the thing is that binomial PDF, right? PDF, your X value is actually gonna be telling you like probability of that exact amount. So in this case, we're going for exactly 1, so we will be using PDF. But just so that we're all, informed, in CDF, your X value is probability of that amount or less. All right, so it's very different. One of them is exact amount, the other one is that amount or less. See? So that is the difference between PDF and CDF. Of course, we will be using PDF in this scenario, but they do ask for the same things. All right. Awesome. So trials is going to be 10. My probability is something that I have not found yet, and my x value is going to be 1. And so which probability are we talking about? We're talking about the probability that one of these cats weighs over 6.25 kilograms. So how can I find that? Well, I'll go to distribution, normal CDF. My lower is going to be 6.25. My upper is going to be, I don't know, a very big number. See? So this is going to help me find out the probability that any cat weighs over 6.25 kilograms. I plug in the mean, plug in the standard deviation, much like the rest of the problem. We get this amount, see, 0.382. So this is going to be 0.382. 0.88. See what? Why not? Why not? So now using this information, I can go ahead and plug it into the other one. We said it was going to be binomial PDF because we're talking about exactly one of them. See, exactly one of them. This is a buzzword. If you see exactly, you should immediately think, okay, we're talking about PDF, binomial PDF. And yeah, that is a key buzzword actually that can help a lot. If you find exactly, you should be thinking PDF. So trials was 10. Probability is this thing that we just found. And x value we said 1 because we're looking for exactly one cat of those 10 weighing that amount. We get this, see? Which actually makes sense because if the probability of, if 38% of all your cats weigh more than 6.25 and you pick 10 of them, getting only one of them that weighs that amount would be like unlikely, see? And in this case, we did get an unlikely number. We got 0.05. 0.17. Right? And that, as a percent, is pretty much just going to be, or actually first doing the significant figures, 0.0502, which is no different than 5.02%. So that's a pretty low number. It makes sense that it's pretty low. And so yeah, that is part E. 10 of the cats are chosen at random. They're probably the one of them, exactly one, weighs over 6.25, is this percent down there. See? The biggest buzzword that I noticed near the end is exactly. Okay, exactly is a very big hint for knowing that it's PDF. Remember the difference between PDF and CDF. Yeah, that is number 4.